Today we will continue with the different types of chemical reactions. We have already discussed about the combination reaction and decomposition reaction. Today we will be discussing about displacement reaction and double displacement reaction. A reaction in which a more reactive element displaces a less reactive element from its compound is known as a displacement reaction. So a reactive element displaces a less reactive element. So let's see the general formula. The general formula is A plus BC gives out AC plus B. So if you see, B has been replaced by A. So BC now becomes AC and B has been displaced by A. Let's see the first example where iron displaces copper from a solution of copper sulfate. Iron or Fe plus CuSO4. Now when it reacts, we will find that Cu has been replaced by Fe. So the product becomes FeSO4 plus Cu. So if you compare with the general formula, Fe is A, Cu is B, SO4 is C. So now B is replaced by A, that means Cu is replaced by Fe. So the product becomes FeSO4, that is AC, and since Cu is B, it will be displaced. The color change in this reaction is very important. If you see, the reactants, iron is gray, copper sulfate is blue, but the products that is formed is pale green and reddish brown in color. So when you write the reaction, you have to mention the change in color also. Next example is the reaction of copper and silver nitrate. So if you see the reaction, copper Cu is A, Ag is B, NO3 is C. So B will be replaced by A, so the product will be AC, that is CuNO3, and B has been replaced. In this reaction also, note down the color change. The reactants, copper is reddish brown, whereas silver nitrate is colorless. The product, copper nitrate, is blue in color, and silver is obviously silvery in color. The next reaction is known as double displacement reaction. In the previous type of reaction that we did, that is displacement reaction, only one element was being replaced or displaced. But in double displacement reaction, two elements will be displaced. So a chemical reaction in which two compounds in their aqueous solution, that means they have to be mixed in water, will interchange the ions to form a new compound. This type of reaction is known as double displacement reaction. Now let's see the general formula. If you see the general formula, you will see AB plus CD. So the reactants are AB and CD. Now I told you in double displacement reaction, two elements are replaced. That means exchange of ions takes place here. So instead of AB, now it will become AD. That means B and D have been exchanged. So the product becomes AD plus CB. So see here, B and D have been exchanged. So in place of B, D will come, and in place of D, B will come. So here two compounds or two elements are being exchanged. So it is called a double displacement reaction. Now, double displacement reaction are of two types. The first type is known as precipitation reaction. Here, one of the product is an insoluble solid, which is known as a precipitate, and it is represented by a downward arrow. So a double displacement reaction in which a precipitate is formed is known as a precipitation reaction. And what is a precipitate? It is an insoluble solid. See the first example, that is reaction between sodium chloride and silver nitrate. Here Ag is A, NO3 is B, Na is C, and Cl is D. According to the general formula, B and D are exchanged, so the product becomes AgCl and NaNO3. So here B and D has been exchanged. Now AgCl is a precipitate, that is an insoluble solid. So since a precipitate is being formed in a double displacement reaction, this type of reaction is known as a precipitation reaction. If you see the equation within the brackets next to AgNO3 and NaCl, AQ is written. AQ means aqueous solution mixed in water. We should always remember that in a double displacement reaction, we should always take aqueous solution. And look at the color of the precipitate. It is white, so you have to mention the color of the precipitate also, and the precipitate is denoted by a downward arrow. Upward arrow is gas, downward arrow is precipitate. Now see the next example, reaction between barium chloride and sodium sulfate. Here Ba is A, Cl is B, Na is C, and SO4 is D. We know B and D has to be replaced. So the product will be BaSO4 NaCl. Here barium sulfate, that is BaSO4, is the precipitate. So downward arrow, it is curdy white in color. The reactants barium chloride and sodium sulfate should be in the aqueous state. So this is another example of a double displacement reaction in which a precipitate is formed. Let's see the last example, that is a reaction between potassium iodide and lead nitrate. Lead nitrate is PbNO3 twice. Potassium iodide is Ki. Here Pb is A, NO3 is B, K is C, and I is D. We know that in a double displacement reaction, B is replaced by D. So the product will be PbI and KNO3, that is lead iodide and potassium nitrate. The lead iodide is the precipitate, so we put a downward arrow. It is golden yellow in color. The reactants lead nitrate and potassium iodide should be in the aqueous solution, so we write AQ within the brackets. So always remember, in a double displacement reaction, the reactants should be in the aqueous solution and two ions are exchanged. That means B is and D are exchanged. And if a precipitate is formed in a double displacement reaction, it is known as a precipitation reaction. The next type of double displacement reaction is known as a neutralization reaction. It always takes place between an acid and a base. Whenever an acid reacts with a base, always salt and water is produced. Remember, whenever acid reacts with a base, a salt and water is produced. Hence, it is known as a neutralization reaction, but it follows the same general formula of the double displacement reaction. So, let's see an example of a neutralization reaction. The reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide is a base. Hydrochloric acid is an acid. We know whenever a base and an acid react, it gives salt and water. So here sodium chloride is the salt. Now let's compare it with the general formula. Na is A, OH is B, H is C, Cl is D. We know that B and D are exchanged, so the product becomes NaCl and H2O. Here, two atoms of hydrogen. There was only one atom of hydrogen. Now it becomes two atoms of hydrogen because B was OH. So here also it follows the general formula of a double displacement reaction, only that it is an acid and a base reaction, so it is called a neutralization reaction. Let's see one more example. The reaction between copper oxide and sulfuric acid. Copper oxide is the base, sulfuric acid is the acid. Cu is A, O is B, H2 is C, and SO4 is D. B is exchanged with D, so the product will be CuSO4 H2O, that is base plus an acid always gives salt and water, so the salt here is copper sulfate. So in a double displacement reaction, always B is exchanged with D, and in case of a neutralization reaction, it is a reaction between an acid and a base where salt and water is produced. Neutralization reaction, that is a reaction between an acid and a base to produce salt and water, is applied in our daily lives. So just see the different applications of neutralization in our daily lives. Like the toothpaste that we use is actually a base, and acid is produced in our teeth. So when we brush our teeth using a toothpaste, a neutralization reaction takes place, and acid reacts with the base to produce salt and water. And then similarly, baking powder is used to rise cakes when we prepare cakes. Then when a bee stings, when any insect stings us, it leaves an acid in our body. We can apply baking powder, which is a base, to neutralize the reaction. Then the next one is when you have indigestion, you take antacids. So when indigestion takes place, acids is produced in our body. The antacid that we take is a base. So the base and the acid neutralize the reaction. While growing plants, the soil is treated with many fertilizers. Now what happens is the soil is actually acidic. So when you add fertilizers, which is a base, a neutralization reaction takes place, neutralizing the effect of the acid on the soil. So just see the table or the chart that I have put up, and you will see the various uses or practical applications of neutralization in our daily lives. Now, a reaction may be exothermic or endothermic. We already know that a reaction in which heat is produced is known as an exothermic reaction, and a reaction in which heat is absorbed is known as an endothermic reaction. So see this example: calcium oxide plus water gives out calcium hydroxide plus heat. That means heat is produced. You can use a delta sign here. So it is obviously an exothermic reaction in which heat is produced. Calcium oxide is also known as quicklime. So this reaction can be termed as dissolution of quicklime in water. See the next example: sodium hydroxide plus hydrochloric acid. This is also a neutralization reaction which is exothermic because heat is produced. The next example is reaction between nitrogen and oxygen. Here 3000 degrees Celsius of heat is absorbed, so it is an endothermic reaction. or the temperature has to be maintained up to 3000 degrees Celsius. So heat is being absorbed, so it is an endothermic reaction. The last example, decomposition of calcium carbonate. Calcium carbonate decomposes at a temperature of 1000 degrees Celsius to give calcium oxide and carbon dioxide. So here heat is being absorbed, so it is an endothermic reaction. So remember, any reaction in which heat is given out, exothermic, and if heat is absorbed, endothermic reaction. See the concept map. There are four types of chemical reactions: combination, decomposition, displacement, and double displacement reaction. If in a double displacement reaction a precipitate is formed, then it is a precipitation reaction, and if an acid reacts with a base to give salt and water, it is known as a neutralization reaction. Then in any of these chemical reactions, if heat is produced, it is known as an exothermic reaction, and if heat is absorbed, then it is known as an endothermic reaction. So with this, we end the different types of chemical reactions. Thank you. Bye-bye.